Hey everyone. This is going to be the first lesson for Unit 11. We're pretty much going to start off this entire lesson is going to be a recap of a lot of the power rules that we talked about in, I believe it was the first unit. So for example, here are a bunch of the older rules. I'll go through some of these. So the first is the product rule. When you have two terms being multiplied that share the same base, in this case a, what we do is add the exponents. So a to the m times a to the n would become a to the m plus n. Over here, the quotient rule. Here, once again, we have similar bases, and when we divide, instead of adding the exponents, we're now going to subtract the exponents. The third rule that we talked about was the zero exponent one. This one's easy. Anything raised to the zero power is equal to 1, always and forever. Then if we go down to the power rule, when we have a power on the outside of our brackets, it gets distributed in and multiplies with our previous unit. So this time we actually have m times n. To piggyback off of the power rule, there's this one, the power of the product. So here the n is being distributed to both. Now notice I'm not multiplying both terms by n, but rather raising each term to the n. So this is a combination of the power rule and just the idea of distributing. The last one is the negative exponent. Here, the idea is that you're going to get rid of the negative by moving the term into the other side of the fraction. So currently, if I tried to turn this into a fraction, it would be a to the negative m over 1. So to get rid of the negative m, I just move the whole term to the bottom. So this becomes 1 over a to the positive m. Or on the flip side, in the case of the second one where we have 1 over a to the negative m, we flip the a back into the numerator, make the exponent now positive, and it becomes a to the m. So I would recommend that you try doing these questions yourself. So here, again, the product rule, we add the exponents. So the exponents are 2 plus 3, and I'm going to keep the base the same. 2 plus 3 equals 5. So my answer will be 3 to the 5th. For this quotient rule, do the same thing. The base stays the same, and then I subtract the exponents. 11 minus 3 is 8. So this is 3 to the 8th. The zero exponent one, 4 to 0, is the same as anything to the 0, 1. Scrolling down to here. Power rule, I'm going to keep my base the same, and then I'm going to move the 3 and multiply it by 2. 3 times 2 is 6, so my answer is 2 to the 6th. Down here, I'm going to distribute this power to both terms. Again, note that the power is going to each term. So the 2 gets the power of 3, and a gets the power to the 3. Then in our calculators, we just plug in what a to the 3rd is. And this can be simplified one step further as 8a to the 3rd. Similar thing over down here with the negative exponent. Right now, my 2 to the negative 3 is in the numerator, so I'm going to put it in the denominator. And once again, 2 to the 3rd, I can rewrite as 1 over 8. The second example is the same thing, except this time the number in the denominator, the 2, is now brought to the numerator, and the exponent now becomes positive. And when I plug in my calculator, 2 to the 3rd is 8. So this is just a recap of each of the rules. And then the rest of this worksheet and lesson is just seeing examples and practicing examples where we have multiple rules going on at once. So again, I always recommend that you try working on some of these yourself, but if you want, I'll continue going through. So one rule at a time, essentially. So for this first one, we have 2x to the third times 2x squared. What I'm going to do is, instead of distributing the 2 and the 3 inside the parentheses, I'm actually going to treat the 2x as my base, since I have a 2x here and here. And I'm going to add the exponents. So this becomes 2x to the fifth. Now I can use the power of the product rule, where I distribute this power to both terms. So this becomes 2 to the fifth, x to the fifth. Taking it one step further, just to get, since this exponent isn't that large, I can plug in my calculator and get that 2 to the fifth is actually 32. So in simplified form, I would write it as 32 x to the fifth. Over here, we are going to do the quotient rule. So remember that when we don't have an exponent on something, the exponent's actually 1. So for the a, I have 1 in the numerator, and I have 2 in the denominator, so it's 1 minus 2. And then for the b, I have 9 in the numerator and 6 in the denominator, so it's 9 minus 6. So when I do this, I get a to the negative 1, b to the third. Again, I don't like this negative on that a, so I'm going to make it positive by moving the a down to the bottom. So my answer ends up being b cubed over a. Scrolling down to the next one. So this one is a little bit different than before. I want to actually get rid of all the parentheses. So before I can do that, I want to distribute the square to both terms. So 3 squared x squared. These other two terms, 5x fourth y and the negative x y cubed, they don't need their parentheses anymore. I'm just going to keep it on the x for a second. Now what I'm going to do is kind of rewrite this so I have all the coefficients on one side all together, all the x's together, and all the y's together, just to make my life a little bit easier. So I have 3 squared, which can be rewritten as 9. The next quotient I have is 5. And then, or sorry, coefficient. And then over here, if you actually look, I have a negative in front of that x. So I'm actually just going to move the negative over here. Now I can have all my x's together. X squared, x to the fourth, x. And then y and y to the third. Putting this all together and doing it step by step. 9 times 5 is 45. X squared plus x to the fourth plus x to the 1. 2 plus 4 plus 1 is 7. And here we have y to the first plus y and y to the third. So we're going to add those exponents as well. So my final answer would be negative 45, x to the 7th, y to the 4th. All right, for number 4, starting off with the getting rid of that negative exponent, this entire term is going to go in the bottom. So I have nothing up top except for a 1. Then I end up with 2x squared cubed. Again, that negative 3 becomes positive once I move it to the bottom. 4x cubed squared. Doing power of the product rule, I'm going to distribute these powers to each term. So it's going to be 2 to the third, x. I already have a 2 here, so they're going to multiply, x to the 6th. The 4 is going to get a square. And once again, I have a 3 there, so those these numbers multiply, and I get x to the 6th again. Doing something similar I did in number 3, where I just move all the coefficients together. I get 2 cubed, which when you plug in the calculator, remember was 8. 4 squared is 16. And then I have an x to the 6th times x to the 6th. I'm going to add these exponents from the product rule. So that becomes x to the 12th. Then doing one more calculation, just doing 8 times 16 gets me 1 over 128 x to the 12th. Down to number 5. This one's actually pretty straightforward since there's only one rule. We're just going to do the power of the product rule where we distribute that power to each term. So it's going to be 3 squared x squared over 2 squared. Then in the calculator, I just need to figure out what each of these terms are. 3 squared is 9, and 2 squared is 4. There's no way for me to simplify that fraction, so that's as simplified as it can get. So I'm just going to leave it as is. Number 6, my eyes immediately drawn to that 0 because we can use the 0 power rule and realize that this is just a 1. So realistically, I only care about this term. So I'm going to distribute the 4 to each part. So I get a negative 5 to the 4th, s to the 4th, t to the 4th. There's nothing else I can do with those variables. So the only number that I have to simplify is the negative 5 to the 4th. When you plug this into the calculator, you get a positive 625 s to the 4th, t to the 4th. It's extremely important to note that in the calculator, whatever calculator you use, doing this, negative 5 to the 4th, is not the same as doing negative 5, 4. When you get it in the calculator, what you'll end up getting, if you put parentheses around the number, you get the positive 625. If you don't put parentheses, you end up getting negative 625. The calculator misreads the negative and doesn't think it's part of the power. So you have to make sure that you put parentheses around it in order to get the sign correct. All right, down to number 7. So what we're going to do is distribute, we're going to get rid of the negative exponents here. So the 2x to the negative, to the 4th goes on the bottom, and the 3x squared goes on the bottom. Now I'm going to distribute the powers. So I still have that 3 in the numerator. Then I get 2 to the 4th, x to the 4th, 3 squared, x to the 4th. Plug it into my calculator. 2 to the 4th is 16. 3 squared is 9. And then we have x to the 4th, x to the 4th. By the product rule, that's going to be x to the 8th, adding those exponents. In the calculator, 16 times 9 gets me 144 x to the 8th. Now I have to simplify the fraction. I have 3 divided by 144. So in a calculator, ideally a graphing calculator, you set this to give you the most simplified fraction, and you should end up with 1 over 48 x to the 8th. And that's your most simplified answer. So for this one, you can actually do it a few different ways. I'm actually gonna, what I want to do is I kind of want to simplify what's inside the parentheses first. So we have an r to the negative 3 in the numerator, and I'm going to subtract the 4 that's on the bottom. So I end up with 3r, negative 3 minus 4 is also negative 7. All right. Now what I'm going to do is distribute the negative 1 to both terms. So I get 3 to the negative 1, and negative 7 times negative 1 just becomes a positive 7. From here, the only term that still needs to be simplified is this. 3 to the negative 1 means that the 3 goes into the bottom, the r to the 7 stays in the numerator, and this ends up being my simplified term. All right. So we'll just do some independent practice questions real quick. So over here, we're going to distribute the 5 power to both sides, to both terms. So again, we're multiplying the power, so 3 times 5 is 15. And for the W, 4 times 5 is 20. Because they don't have the same base, I can't do anything else. So that is my simplified term. Over here, again, I want to try and simplify each thing first. So 7 divided by 21. Well, this actually simplifies to be 1 over 3. The g to the negative 2 term, it's the only g there. So what I can do is I can actually move it to the bottom and make that exponent positive. And then over here, I have an h to the 4th and an h to the 4th. When I subtract them, I get h to the 0. But as we know, through the 0 power rule, we know anything to 0 is 1. So this actually simplifies to 1 over 3g squared. Okay, number 3. There's really nothing we can do inside the parentheses. So I'm just going to go about distributing the power to each term. So the 4 gets a cubed. The x squared, the 2 gets multiplied by that 3, so it becomes x to the 6th. The y gets a cubed, 3 gets a cubed, and the a gets a cubed. Those variable terms, the x, y, and a, can't be simplified in any other way. So we're just going to figure out what 4 cubed and 3 cubed are. So 4 cubed is 64. Everything in the numerator stays the same. And then 3 cubed is 27. So this ends up being my most simplified form. Okay. For the last question, there's nothing I could do inside the parentheses, so I'm just going to go about distributing the power to each term. So 5 multiplied by 3 is 15. X 4 times 3 is 12. And for the y, 6 times 3 is 18. Now in the new denominator, we have a y, an x, and a w. So we're going to do the quotient rule for each one. 15 minus 1 is 14. 12 minus 2 is 10. And for the y, 18 minus 4 is 14. And that's it. There's still the closing assessment questions and the homework questions. So make sure you go through these. If you have any questions, please let me know. And make sure to submit all your work. Have a great day.